data manipulation. So data manipulation is required to bring accuracy and precision to your data, and the R base package has apply functions within it. And this will work in manipulating the data multiple times, so you don't have to create a variety of loop constructs. So the apply functions are absolutely phenomenal, and they are used very commonly in the real world. There's a variety of types of apply functions within R. So we have base apply, L apply, S apply, T apply, M apply, V apply, and R apply. The apply function helps apply a function to a matrix, row, or column, returning a vector, array, or list. Well, what does that look like? Well, using the syntax, we have apply x, the margin, and the function. So x may be our vector or variable name or data frame. The margin is how we explicitly define what we're trying to compute on. So when we have the margin equal 1, that means we're applying it across the row. If the margin is equal to 2, the function is applied to the column. And there's a variety of functions that can be applied, which can include things such as mean, sum, or average. So in this case, if we created a 2x2 matrix containing 1, 2, 3, 4, and we used apply on M, our matrix, 1 is applied to a row, and we're looking to sum that row then. Now if we have apply, where that margin is set to 2, we're going to sum across the columns. So what this would do is create a vector with 2 numbers for each of these. Now the lapply function takes a list as an argument and works by looping through each element within that list. So thus the output of that function will also be a list. So at base, the syntax is using the lapply function of whatever our list name is, and then the function that we want to apply to it. So if you see below, we have a list containing 1, 1, 2, 2, 3, 3. We can use the lapply functions to sum across that list, to use the mean, and a variety of other functions as well. sapply will probably be applied for you more commonly than lapply because it can handle most things that lapply does. It also simplifies the process. So if you're using sapply and your result is a list, every element within that list is of size 1, then you'll get a vector. However, if the result's a list, every element is greater than 1, then you'll get a matrix. And if neither of those cases applies, then it'll just return the list itself. So here we're using the sapply list and whatever function. So again, it works just like lapply, where we're using that list and then we're computing some sort of function, whether it's a sum or range, min, max, etc. Now, that's within base R. One of the most heralded packages within R is called DPlotter. And this package is used exclusively for data manipulation. It's very commonly used. It's one of the first packages most every data scientist loads into the library once they start R, because it's a very powerful package. So for using DPlotter, we're wanting to transform and summarize these tabular data with the rows and columns themselves, right? These matrices, arrays, data frames. Now, the functions correspond to data manipulation types to help translate these thoughts, these things that you want to do, into code in a much more easy way. It's very clean syntax. It's very easy to work with. So we'll go through select, filter, arrange, mutate, and summarize. And the data storage backends within DPlotter, because of its code, allows for extremely rapid processing speed compared to some of the base packages. If we're going to go into each of these functions, let's look at a built-in package within R called mtcars. mtcars is a built-in data frame with car data. So let's look at the select command. If we wanted to select columns by name, we're selecting from the mtcars dataset, data frame, and we want the columns mpg and disp, displacement. We could also specify columns as a from to. So here, again, we're selecting the mtcars data frame, but we want all columns between mpg and hp. One of the other great things that the select function can do, especially if you had, let's say, 20,000 columns, 20,000 variables, let's say they're genome sequencing. Well, sometimes you need things that start with or end with or contain, and you don't want to manually go through all those and try to manually find them. So here we're selecting from the iris data frame, another data set built into base R, and we're saying, give us all the data, all the columns that start with the word petal. Or from the iris data frame, give us all of the columns that end with the word width, or contains etal, or even has matches within it. So it's a very powerful tool, especially as your data sets get larger and larger, to subset that data or to find the data that you need to work with. Filter is another function for filtering out data. Because we might want to dive into data or to create a subset of data to work with, we'd want to use the filter command. So we can use simple or multiple criteria type filters. So here we're going into the empty cars data frame again, and we're wanting to filter. And here we're saying, okay, instead of all of the data that's in your data frame, give me only the cars, only the data where the cars have a cylinder equal to 8, or where the cars have a cylinder less than 6. And you can subset that data and then work with that data group explicitly. You could also have multiple criterion filtering. So if we're using the empty cars data set, we want all cars with cylinders less than 6 and a VS equal to 1. Or the line below it, you can see the slash means or a VS equal to 1. And just as a side note, if you're using comma-separated arguments, it's equivalent to the AND condition. So just like that first one on the multiple criteria filter, you could use sil less than 6 and the ampersand, or you can use a comma, and they both work the exact same way. Now, a range is very useful, especially for looking through the data when you're exploring it, because you can arrange that data in a specific order, ascending, descending, etc. So let's say we wanted to look at the displacement of these vehicles. So we would arrange the data using the empty cars data set in descending order of displacement. We can also use multiple criterion. So in this case, we're looking to arrange empty cars first by cylinder, so 4, then 6, then 8, and then by displacement. So within the 4 cylinders, those would be created in ascending order, and then within the 6, those would be created in ascending order, and so on. We also have the mutate command. So this function helps add new variables to an existing dataset. And the syntax to use this function will look as below. So an easy way to create a new variable, you could easily do something like this manually, but mutate can handle much more complex type queries. So in this case, we're saying, okay, well, the displacement variable is good, but for whatever reason, I want to customize it and create a variable called myCustomDisp and use the original displacement variable divided by 1.0237. And that will automatically create this new variable and add it to the empty cars dataset. Lastly, within DPlotter, we have the summarize function. So we can summarize multiple values and also a single value within it, or down to a single value in a dataset. So if we're wanting to summarize mean displacement by cylinder, what this will do is essentially give us a vector, right? We have 4, 6, and 8 cylinder cars in this dataset. So it would compute the mean displacement of all the 4 cylinder cars, the mean displacement of all the 6 cylinder cars, and the mean displacement of all the 8 cylinder cars. There's also other functions, such as the mean of the displacement, again grouped by cylinder, and the standard deviation of that. So here's a list of summary functions that we can use within this function as well. Within DPlotter, first we'll return the first element of a vector, last will return the last. Nth returns the nth element of a vector. N with parentheses will return the number of rows within a data frame, and distinct will return all the unique values within that vector itself. And then we also have a lot of basic commands, right? So we have the mean, the min and the max, the median, the mode, sun, var, length, and IQR, which is the inner quartile range. So if you're a data scientist